This is Geometry, Chapter 5, Lesson 1. Up to this point, we have dealt with equalities. In this chapter, we are going to deal with inequalities. So something is not equal to something else. Therefore, well, it might be equal to. And actually, with inequalities, there are really three options. Either A is equal to B, that's one option. A is greater than B, that's another option. Or A is less than B. Obviously, we could have A greater than or equal to B. We could have A less than or equal to B, so that's the other two options. And these are variables that represent real numbers. And that is actually the very first property. The three possibilities. This is also in, I believe this is in your Algebra 1 textbook. But maybe y'all didn't get that far, actually. All right, so this is the three possibilities, right? One number is equal to another number. One number is greater than another number, or one number is less than another number. There's only three possibilities. All right, let's just look at A greater than B. So I can use the same properties of equalities that I can with inequalities. So I could add any value to both sides. Okay, just went over this in Algebra 2 again today, except with equalities. Without changing the inequality. As long as I add the same value on both sides of the sign, I do not change the inequality. The reason would be addition. I can subtract the same value from both sides without changing that inequality, and that would be called subtraction. All right, you following me? All right, so with addition and subtraction, all I'm doing is adding the same value or subtracting the same value. Multiplication and division are different. So if I begin with A plus C greater than B plus C, okay, if I begin there, and I want to apply multiplication, and let's say I'm going to multiply both sides by X. I have to multiply every term by X. I can't just multiply one. So it's going to be AX plus CX greater than BX plus CX. So you see how multiplication is different than addition and subtraction. Addition and subtraction, I just one number both sides. Multiplication, I have to multiply every term by that value in order not to change the value. Yes?
Does it matter like the order they're in?
Could have been XA plus XC. So that's multiplication. Why? Multiplication. All right. Now, let's look at division. Division is like multiplication. Let's just go less than. We'll make it B plus D. Let's say I begin here, and I want to divide. Let's say by 2 on both sides. I have to divide every term by 2. I can't just pick and choose a term to divide by 2. The only way I do not change that inequality is if I divide every term by the same value. And the reason would be division. So do you see how addition and subtraction are different from multiplication and division? Multiplication and division is applied to every term on both sides. Addition and subtraction is not. You're just adding the same value, you're subtracting the same value. There's one more property called transitive. And transitive is very close to substitution. So let's look at substitution first. And let's compare it to transitive and how it's different. So substitution would be something like, that's like substitution. What did I do? I took this first equation, and where x is, I substituted 3y. All right, do you see substitution? Transitive is more like for this one, I probably would also take substitution, actually. But in inequalities, it's if A is greater than B and B is greater than C, then A is greater than C. So if I have 1 greater than 2 and 2 greater than 3, then the first one's greater than the last one. This is 100% of the time transitive. It is never substitution. You see this? All right, look at the addition theorem. It is different than just addition because we begin with 2 inequalities. So this is going to be the addition theorem. The addition theorem of inequality says if I have A greater than B and C greater than D, I can add the two values to the left of the sign and add the 2 values to the right of the sign, and the inequality doesn't change. So I can say A plus C is greater than B plus D. Okay, let's just use practical numbers. 5 is greater than 3 and 6 is greater than 2. Do we agree with those?
Yes.
So what would the addition theorem tell me I can do, Selby?
It would tell you that 5 plus 6 is greater than 3 plus 2.
And is that the case? Yes. 11 is greater than 5. So the addition theorem takes 2 inequalities and looks at both sides of that inequality and adds the numbers on the greater side and adds the numbers on the less than side. Does that make sense?
Yes, sir.
All right. All right, look at the whole greater than a part. All right, we're gonna actually give an example. So I'll give it with a line. What does betweenness of points tell me? What would be the equation for betweenness of points? Megan?
A dash B dash C.
Okay, A dash B dash C such that what equation is true, Elliot?
AB plus BC equals A dash B dash C.
Right? That this section plus this section equals the whole section. Got it? The sum of the 2 pieces of AC equals AC. Make sense? So AC is the whole, right? And here we have the parts, right? This is what whole greater than any part says. I can say AC the whole is greater than AB. Is that true?
Yes.
Yes. I can also say that AC is greater than BC. Is that true? You see whole greater than a part? Do you understand that concept? You got it? Do you understand it?
Yeah. I got it.
All right, let's look at it with an angle. All right, what does the betweenness of rays theorem tell me? We have OA, this was on your test, OB, OC, such that what is true? David?
Angle AOB is equal
AOB.
dash
Plus
Finish it. Plus, Landry?
BOC,
Plus what?
BOC
Yes.
equals AOC.
So AOC is the whole angle. You agree? AOB is part of that angle. And BOC is part of the big angle, right? So whole greater than part says I can take the whole, that whole angle AOC. It's greater than angle AOB. And I could say angle AOC is greater than angle BOC. That's whole greater than part. Does that make sense? Yes, ma'am?
Yes, ma'am.
Okay, thank you. All right, let's work a couple of proofs. Let me draw it. It always helps me to draw it, even if it's not drawn. Most of you are not marking your triangles. Okay, so here's the given statements. This is what we're going to prove. All right, so we begin with the given statements, right? And some of you did not. I thought this would be the first class. Remember, it's a two-column proof. We have the statements and we have the reasons. Label your columns, number. All right, so we have the measure of angle ABC equals the measure of angle 1 plus the measure of angle 2. Why? Given. Then we have the measure of angle 2 is greater than the measure of angle 3. And the reason, given. All right. Now, what can we say? We have that 2 is greater than 3. I want to get to ABC greater than 3. Can we say something about this first statement? What can we know from this first statement? Okay, I just did it with the previous example. What can I know about this first statement? What is this first statement really? It's betweenness of rays. Yes. Selby, what can I know?
You know that angle 1 plus angle 2 equals angle ABC?
And that's already written, yes. What can I know from the statement, Megan?
That angle ABC is greater than angle 1.
I can know that that is true, and I can know, you were gonna say it?
The angle also greater than angle 2.
Measure of angle ABC is greater than the measure of angle 2. And why? Why can I say that? Selby?
Because the whole greater than part theorem.
Whole greater than part theorem. That's why I can say that. Okay. Now, what would we say next? What do you think would be next? Do you see it, Alexis? It's also from this lesson.
What does the M stand for?
Measure, measure. M stands for measure, measure of that angle. I don't want y'all to look. I have ABC is greater than 2. I have 2 is greater than 3. What do you think, Isabella?
Would it be that ABC is greater than 3?
Yes. Why can I say the measure of ABC is greater than the measure of angle 3? Yes.
Would it be because of trend?
It's transitive. Right? First greater than second, second greater than third, therefore first is greater than the third.
Oh.
You see it? Because of transitive. All right, let's look